Hello viewers, today we are going to discuss about alternating current. So let us discuss about what is alternating current. Here as you can see, current which change its direction is known as alternating current. Now let's jump into another point, which is AC generator or alternating current generator. Here there are some formulas which you should know in for your exams. First formula is theta is equals to omega t. Here theta is angular distance, omega is the angular velocity, and here small t is the time. Next formula is phi equals to b vector dot a vector. Phi is flux, b is the magnetic field, and a is the area vector. Now the third formula is electromagnetic field, E. We can you can denote it in like this or like this as well. Both are your choice, no issues. So we know that EMF is equals to minus d phi by dt. So now we can say if we differentiate this phi, then we get minus capital N B A omega sine omega t. Here capital N is the number of turns in the number of coils in the AC generator. B is the magnetic field, A is the area of those coils, and omega is your angular velocity at which those coils are rotating in this AC generator, and sine omega t is a function. Now let's get into another formula, which is epsilon equals to epsilon naught sine omega t. So epsilon naught is your peak value and sine omega t is your function. Now let's get into another formula, which is the current. How to calculate the current passing through the coils in the AC generator. So to do that, we will gonna divide this epsilon divided by its resistance. If we do it, then we get this formula: N capital N B capital A omega into sine omega t plus phi divided by capital R, which is going which we can also write the I in this format: I naught sine omega t plus phi. You can, both formulas are important, you should remember all of them. Okay, now let's get into another point, which is average value of alternating current or AC. So for this, let's calculate the current I for the total time period t. How are we going to calculate it? Well, very simple. In order to do this, we are going to calculate use this formula: I naught sine omega t plus phi, and we have to integrate this in the total time period of uh, from 0 to total time period t. T means the capital T. So here we did the same thing. So here is the formula: I naught sine omega t plus phi, I naught sine omega t plus phi into dt divided by small dt integration of 0 to capital T. Okay, I should write this thing here for your understanding. Now if we integrate this, then we get minus I naught omega cos omega t plus phi from 0 to t by capital T. We know the integrations, like let me just give you a quick review. Like we all know that if we integrate sine function, then we get this cos sine, then we get minus cos, and as there is omega t plus phi, we have to again different integrate this function omega t plus phi. Then if we integrate this, then we get omega. Okay, so after doing this step, we get into another, then we just put the values of another, then we get minus I naught by omega t into cos of omega t plus phi minus cos phi, then equals to, you can also write this format into this as well. Both are sorry, both are useful, you can choose any one, not a big issue. Now let's get into another point, which is over half time period. So if you want to calculate the current into a over half time period, over half time period means this is your total full time period, means this one total t, and if you want to calculate a half time period, means only this one. Okay, as you can see it now. So in order, if you want to calculate the current in the over half time period, then again here we are going to put pi instead of this omega t. We have put in pi, so cos pi plus phi minus cos phi, and here it will be 2 I naught by omega t equals to, again what is going to happen, we are going to write this omega t as 2 pi. So if we write it as 2 pi, then what could have happened, then 2 by 2 I naught by 2 pi, 2 to cancel, so I naught by pi, which I already written in the just few minutes back, but just for your easiness I just written this. So is I naught by pi, and we all know that cos pi plus phi, it means it lies in the third quadrant. It means, you know, in the third quadrant the value of cos is always negative, so that's why it will be minus cos phi. It will be always minus cos phi. So minus cos phi minus cos phi minus 2 cos phi, and we can write this as 2 I naught cos phi by pi. Where did this minus go? Well, there is minus, is another minus, minus multiplied by minus will be equals to plus. Now let us talk about some things which is like you should remember it, which is very very important. The first thing you should remember is this: for half time period the flux is 0, the current is 2 I, what happens here? Yes, for over half time period flux is 0 and the current, average current is 2 I naught by pi, and for phi equals to pi by 2 means 90 degree, the average current will be 0. And you should also remember these things, it will help you in graph questions. Now for total time period t, if the flux is equals to 0, then the graph will look like this. It then the phi, and for 90 degree the graph will look like this. Okay, now let's talk about the root mean square value of alternating current. So the alternating current, we know that I equals to I naught sine omega t plus phi. So let us now, if we square it on the both sides, then what we get? We will get this thing. Now we are going to take the account the average value of this one. Here is it. So we are going to calculate the average value of this one. So here we all know the format. This I squared dt, integration of I squared dt by dt. I squared will be this component, and we know the I square means I naught square sine square omega t plus phi dt. Integration will be 0 to capital T divided by small dt, integration of small dt from 0 to total time period t. Okay, if we do the total integration, we get this I naught square by 2. Now if we want to calculate the root mean square of this, it means we need to root mean square of this one, then it means we just need to do the square root of this. Then we have did this, and now we get this value, which is I RMS equals to I naught by root 2. This is also important formula, remember this. Now we get into another topic, which is AC circuit containing only resistors. There is now just a basic formula, just remember this, not much to remember. The flux should be equal to 0, and I naught, it means I naught should be epsilon naught by R. That's it. Now for the AC circuit containing only capacitor, again what you need to remember, this one Q equals to C epsilon naught sine omega t. Then another one which is I equals to I naught sine omega t plus pi by 2. Now here there is something which is very important. A lot of times some multiple questions asked in this time, which is like multiple choice questions, this kind of thing, this kind of questions come in the previous years. You can also check it. When you see that I equals to I naught sine omega t plus pi by 2 plus sine, it means that in case of capacitor load, okay, I should write it, a capacitor load, the current leads EMF by 90 degree. Current leads EMF by 90 degree. You should remember this. Now if that is the case, then you should also remember that it also means that in case of capacitor load, the voltage also lags EMF by 90 degree. In case of current, it leads. In case of voltage, it lags. Just reverse things. Just reverse it. Now there is another formula again. The flux should be pi by 2, and the I naught will be epsilon naught by 1 by omega c. This 1 by omega c can be written as xc. Okay. So we can also write this as I naught equals to epsilon naught by xc. You should remember this formula as well, which is very important. This xc is called as capacitive reactance. Capacitive reactance. Now we are going to move to our last topic, which is AC circuit containing only inductor. Here again you should remember on this formula. I equals to epsilon naught by omega L sine of omega t, I equals to epsilon naught by omega L sine of omega t minus pi by 2. It means that the current lags EMF by 90 degree and voltage leads EMF by 90 degree. Current lags and voltage leads, again reverse. Okay. Okay, so this is it, that's it. This is for the today, guys. So I hope that all of you have enjoyed this entire video. So thank you so much. And if you like this video, then do press the subscribe button and press the bell button as well. Don't forget about it. And also do comment on the video on that, on what topic you want the video, that on the what topic you want a video. Okay, thank you so much.